Now here let's talk about how we apply the principle of superposition to combined loads. So what we want to do is so simple. For example, let's imagine that we have structural systems, for example, subjected to a concentrated load and then concentrated moment and then distributed loads. So we have a very complicated situation. And then even we have actual force too. Okay, so let's consider this problem. Then this is what? This is combination of my beam subjected to the actual force plus, and then we have to solve the system for concentrated load, and then we have to solve the system for a concentrated moment, and then also we have to consider the distributed load here. So we have to get a solution for the individual. But here these three are beam problems. But in the case of the first one is not beam problem, isn't it? This is the actual problem, the actually loaded member. So basically we have a support here, support in left hand side. And this guy is equal to, I have one support here, one support, and I have bar subjected to the actual loading. So here we can get the normal stress for the actual loaded member. And how do you do that? So force divided by the cross-sectional area, and then here we use the beam theory. The stress is equal to my divided by I. Okay, so for this problem, in the first problem, let's imagine that we have a cross-section, and then because of this, we have the uniformly distributed normal stress. And then here, this guy produce a stress condition, the anti-symmetric with respect to neutral axis. So on top of this constant load, we have anti-symmetric stress distribution. Isn't it right? Anti-symmetric, by the way, it is tensile, sorry. The compressive and the tensile. So finally, my stress distribution look like this. So make sure that the neutral axis is applied only in this beam problem, not in this actually loaded problems. So in this example, actually I have procedures, but the procedure is really straightforward. First, we have to decompose my structural system into simple units, and then you have to solve the individual problems, and then you superpose all the results. Okay, so let's consider this exam problem. So I have a column, the load is applied in some distance. So first we have to move the load here, then we have one concentrated load, and then by considering this distance, we have a moment, concentrated moment. So we have two different loads, one concentrated load and one concentrated moment. And the second one is we have a load here. And this is we can consider this is concentrated load to the cantilever. That's why we have two different problems. For example, first we have to build a coordinate system, the x, and here the y, and then underlying core is z. Okay, so first in xy place, so I have a beam, and then my beam is loaded by P2, 800 pounds. So are you able to analyze these simple cantilever problems? Yes, it's very easy, right? And then we can determine the shear stress and normal stress. And then I have another one. Is what on XZ plane. XZ plane. So we have another cantilever, and then it is subjected to concentrated moment in this direction. So this is equal to P1 times D, isn't it? Plus And then what's the third one? Third one is actually loaded member. So we have one support and then actually loaded member. Here we have concentrated load P1. So here we have to consider one actual loaded members and the two beam problems. And then we solve the normal stress for individual problems, and then we superpose the normal stress to obtain the final solution. But that's how we apply the principle of superposition to real combined load cases. In real practice, what we do is this: we consider, load case 1 or load case 2, load case 3, and then we consider various different load cases. Okay, and then for the load combination, we can consider load combination, load case 1 plus. So we can choose, for example, let's say we choose load case 1 and load case 3 and load case 4. Then we can consider load case. We can consider there's some problem. We can consider load case 1 or load case 2 and load case 3. Then for different loading conditions. And also, depending on some cases, we can choose only load case 2 and load case 4 only. And then if it is necessary, we can apply the factors. This factor is called the load factor. So first we consider unit load, and then compared to the actual load cases, we consider like 100, 1000 load factors to represent the actual load cases. Okay, so let me start my lecture here. See you next time. So next time we'd like to talk about the buckling, the stability problem. See you.